August was a big month for the Terran R program. Let's recap key milestones across design, build, test, and launch. This month, the team completed 18 component-level critical design reviews, many of which were for the second stage engine, Aeon V, or fluids components. All machined fluids components for the thrust structure have now been released, including all valve components. The stage engineering teams, including structures, mechanisms, and fluids, continue to work hard to close designs for Stage 1 and Stage 2, recently releasing Relativity's first composite parts and increasing their focus on reuse systems, such as landing legs. The thrust structure build is complete. The thrust structure is one of the most intricate and complex parts of the vehicle, so its build required tight collaboration between dozens of teams across the company, as well as the introduction of advanced manufacturing methods to enable high-rate production. In parallel, we finished welding the final Stage 1 barrels for first flight on the vertical friction stir welder. Now, all 8 first stage and 2 second stage barrels for Terran R's first flight have been welded. With barrels complete, first stage tank welding has begun. The first circumferential friction stir weld is complete, joining 2 fuel barrels together. Separately, welding on the first stage downcomer is in progress. The manufacturing team activated the paint booth this month, marking another major production capability now online at our factory. Manufacturing and assembly of the first flight engine is complete. It has been shipped to NASA Stennis, where it will be installed on the stand for acceptance testing. The factory test team activated the structural test stand in Long Beach that will test the thrust structure and first and second stages. Activation was the culmination of years of work and involved building structural and fluid systems, integrating data systems, loading software, and configuring IT systems. The stand is capable of 6 million pounds of compression, 170,000 pounds of shear, and pressures up to 250 pounds per square inch gauge. The thrust structure was loaded onto the stand and began multi-week acceptance testing. On the stand, we tested a flight case simulating max Q and are preparing for a hold-down case replicating conditions on the launch pad. At NASA Stennis, we began hot firing a development article of our second stage vacuum engine, Aeon V. We successfully demonstrated operations across throttle, mixture ratio, and gimbal ranges. The first stage flight engine is being prepared for upcoming acceptance testing on the second bay of the dual bay test stand. 9 commodities tanks arrived at NASA Stennis for the A2 structural test stand. Once installed, they'll be capable of storing 650,000 gallons of liquid oxygen, liquid natural gas, and liquid nitrogen to support stage testing. In avionics, the team made significant progress on the path to completing the vehicle-level hardware-in-the-loop testing this year. Initial avionics hardware has been integrated into the system, and ground software and equipment was used to successfully send commands and receive data from ground hardware to avionics. The first version of vehicle software has been deployed to the avionics system, laying the groundwork for future testing and mission operations. At Cape Canaveral, site work continues to accelerate. This month, we completed a major concrete pour for the transport erector cap. This TE cap will bear the loads of vertically lifting a fully integrated Terran R vehicle while mated to the TE. Water tower fabrication is also progressing, with most of the large storage tank welded, and installation of stanchions for above-ground piping systems is underway to support commodity flow across LC-16. From progress on primary structures and engine testing to enabling infrastructure, August has been another busy month on the path to Terran R's first flight. Stay tuned for more.